In this section, we're going to talk about electronic structure. And as you might imagine, we're going to be talking about electrons because electronic structure is all about them. So we talked about at the beginning of this section or chapter that there was a cloud that electrons were found in. Okay, so this region around the nucleus is where these electrons can be found, and because of where they are and all these pushing and pulling and attractions and repulsions, it gives a particular energy to this system. And so these regions that are being occupied by the electrons are called shells, or also referred to as the principal energy level, and they are designated as lowercase n. And your shells are numbered 1, 2, 3, 4, so integers. And the lower the number, the closer it is to the nucleus, and the lower the energy. And these numbers you're going to see coincide with the period numbers on the periodic table. So lower number shells are closer to the nucleus, they have a lower energy. The electrons in higher numbered shells are going to be farther away from the nucleus and are higher in energy. So also, the larger the shell, the more electrons you can hold. Now, the most electrons you can have in a shell is going to be 2 times n squared. And that's because you can have 2 electrons in the period, okay, that's what n is, and then that's squared. And it works out like this. If you have the first shell, which is going to be closest to the nucleus, you can have 2 electrons. When n equals 2, that's going to be 2 times 2 squared. So 2 times 4 equals 8. The third shell, you have 2 times 3 squared. 3 squared is 9, so 2 times 9 equals 18. So that's how you know how many electrons there are in a particular shell. The shells are divided into subshells. Remember, sub is less than whatever you got, like subatomic particles. So in shells you have subshells. And the subshells of n, whatever it is, are going to have letter numbers S, P, D, and F. We also call, so these subshells, we have orbitals in them. And the orbital is really where we get down to it, where we can find these electrons, or the probability of finding an electron is high, because we can't really tell where the electrons are at any time because they're moving around so fast and they have such high energy. But each of these orbitals can hold 2 electrons. So the S for every one of these shells, you can have 1 S. You could have 3p orbitals. There's 5 orbitals in D, and there's 7 orbitals in F. And so if you remember, if you have an S orbital, okay, you have one of those, and each one of those can hold 2 electrons. So 1 times 2 is 2, so you have a total of 2 electrons in that. I keep touching this, sorry, because when I get down to the bottom it's hard not to touch it. Alright, then I have 3 orbitals possible in a p subshell, so that gives me, oops, 3 times 2 electrons, so that gives me what? 6 electrons, right? And then I have 5 times 2 electrons in a D, and I can have 10 electrons. And then an F orbital, I could have 14 electrons. And so just kind of showing you 1s. Okay, so this is shell number. So this is n equals 1, n equals 2, n equals 3, n equals 4. So I'm getting farther away from the nucleus. In n equals 1, the first shell, I can only have an s orbital, and each one holds 2 electrons, so I have a total of 2. When I get to the second shell, I can have an s orbital, and I can have the 3 p orbitals, so I can have a total of 8 electrons, 2 plus 6. You get to the third, then I can have s, p, and d. So you can have s in the first one, s and p in the second, s, p, and d in the third, and then s, p, d, f in the fourth, and then everything above 4, you can have all 4 of those. Okay, but you're going to have more and more and more electrons as you go out. So what do they look like? Well, they're not just shapes, because it's really the nucleus, you know, is in the center, and then you have this area around it where these electrons could be found. So what we're talking about when we talk about shape in this context is that it's the shape of that orbital, of where those electrons could be. A p orbital looks like a dumbbell. Okay, so you have 3 of those, and they're going to be on the x, y, and z axis. And so all 3 of those are going to look something like that. Now, I can't draw it. You might can. I can't. But so you have an s orbital is spherical, because remember it's 3-dimensional, and then a dumbbell is the shape of the p orbitals. Okay, and then of course in this case your nucleus would be in the center here, and in this case it would be in the center there. Your D's, they get complicated. Okay, they got some dumbbells, they got some donuts, and then the F's are really crazy. So we really only talk about s orbitals and p orbitals in here.